Hello, today we'll talk about inverse trigonometric functions, differentiation. We have four basic trig functions, sine, cosine, tangent, cotangent. Let's talk about the inverse of them, okay? Remember that if you have your function psi of x, this function is defined everywhere, right? So the domain is negative infinity to positive infinity. And if you remember the graph of this function, we have the following. This is x, this is y, this is 0, this is negative 1, 1 right here. Okay, let's say we have pi over 2, this is pi, this is 3 pi over 2, this is 2 pi, okay? So in another one, you have negative pi over 2, negative pi, negative 3 pi over 2, and here negative 2 pi. When x is equal to 0, psi of x is 0. So you start from this point, right? When x is pi over 2, psi of x is 1. So you have this point, okay? And when x is pi, psi is 0. And when x is 3 pi over 2, you have negative 1 in here. And if x go back to 2 pi, you get 0. So basically, the graph of psi look like this, okay? That is from 0 to 2 pi, and so on, right? So you can graph the psi in another part. You have the following one. Yes, let's look like this. This is 1. So of course you can continue this, okay? It's obvious that the function psi of x does not have an inverse on the whole number line. Why? Because on the whole number line, or at least on 0 to 2 pi, the function does not have inverse, because that is not 1 to 1. Right? We know that a function has inverse if and only if it is 1 to 1 function. That means for each x there is only one y, such that y equal to f of x, and for each y there is only one x, such that y equal to f of x. So why are we talking about the inverse of psi? Again, right, if we restrict the domain of the function, so psi of x might have an inverse. Okay, I hope you remember the situation for y equal to x squared, right? This is parabola, but if you restrict the domain, you just consider this part. So the function will be 1 to 1. We do almost the same thing for psi. Okay, so look at this picture. I may choose some intervals so that the function will be 1 to 1 on such intervals. For example, I may choose this one. You see, I may choose this one, and that is from negative pi over 2 to pi over 2. Okay, let me write here. I can choose negative pi over 2 to pi over 2. Okay, or I can choose like from where to where, from pi over 2 to 3 pi over 2, right? Or let's say pi over 2 to 3 pi over 2. Or you might choose like this, this part. It really depends on how you choose, right? But again, those graphs, let's say those pieces, can be obtained from each, right, from another part. Like if you want to obtain this part, right, from this one, yeah, they are symmetric with respect to this guy, you see, or for this part, for this, and then for this, they are also symmetric. So basically, you only need to consider one piece, right? One piece like this or like this, and then you can just extend, right? But if we are talking about the inverse, we need to choose only one into. Okay, so for psi of x, I would choose, negative pi over 2 to pi over 2. Okay, for my consideration. Then, as we have seen that, when x is in between negative pi over 2 to pi over 2, the function has an inverse. And I denote by arc psi of x. Okay, I denote by arc psi of x. That is the inverse of psi. Okay, so basically what is that? If you apply psi of arc psi of x, you get exactly x. Or when you apply arc psi of x, you get x2. These are two identities in the definition of the inverse functions. Alright? Now, let's look at this from another point of view. From the point of view of the unit circle. Because, unit circle is really good tool to understand all this stuff. Let me draw the unit circle, okay? That is x, o, y. So suppose this is 1, this is 1, here is negative 1, here is negative 1. I need to draw a circle. I need to draw a circle in here. Okay, not really beautiful, but I hope it's okay. So on this unit circle, we know this. This is the sine a6. This is the cosine a6, right? Okay, and of course we'll talk about tangent cotangent later. They are pretty simple. So if I have some x in here, in order to find psi, I just need to draw a horizontal line that will intersect with the y-axis at a point that value is psi of x, right? So you can see how we can choose, negative pi over 2 to pi over 2. This is negative pi over 2. This is the pi over 2. Is that correct? So each time, if x is only on this interval, means on this half of the circle, right? For each x, you have one value psi of x, right? And for each value on here, you see, this is, the interval of values of the psi of x. For each value in here, when you go back to the x, you can see there is only one x corresponding to that. You see? So in that situation, your function is, 1 to 1. So psi of x has an inverse. You see that? But if you change the interval, look at this. If you change the interval, for example, you just consider the interval from 0 to 2 pi. You see this? This is 0. That is 2 pi. No, that is just pi. Sorry. That's just pi. So what happened on this interval? For each x, of course, you have one side, the y value, right? But for each y, you have two values of x. You see? So such function will not have an inverse. Does that make sense? So that's why we need to choose negative pi over 2 to 2 pi over 2. All right? Now let's talk about cosine. Again, we can use this picture. Now we don't have to graph the function cosine, okay? We can use this picture to determine the interval where the function y equal to cosine has an inverse, okay? An inverse. All right, I will change this a little bit. I will erase this because I don't need sine. I need cosine, okay? I need cosine. So I don't need sine here. I might erase. Okay, let's erase this. Let's draw another one. Okay, so if you have x in here, you want to find cosine, it's easy. You draw a vertical line. This is the cosine of x. Okay, and Imagine if you have a cosine here, right? And you want to go back to the x. So we do almost the same thing. You need to draw a vertical line. But if you consider some interval like this, on negative pi over 2 to pi over 2, cosine does not have inverse. Does that make sense? Because for each value in here, there are two values of x on that interval. So there's no way. That means we need to change. We don't need to choose that interval, right? I have to choose another one such that, for each value of cosine, you have only one value of x. So that is the one we need. You need to consider from 0 to this. That means from 0 to pi. And you can see for each point cosine here, there is only one and only one point, right, on the circle that is corresponding to cosine. You see? So the cosine has inverse on for x in 0 and pi. You see that? If you look at the unit circle like this, you will see all intervals where the function sine, cosine have an inverse. All right? So we have sine has an inverse on negative pi over 2 to pi over 2. Cosine has an inverse on 0 and pi. Similarly, you can consider the tangent and cotangent. Look at this. Now I can erase this part, right? I don't need cosine here. Now I need tangent. My tangent line look like this. That is the axis for tangent. Okay? And each time when you have an x in here, you want to find the tangent value, you just connect that with the origin that will intersect with this line at some point. That is your tangent value. And of course, the 0 for tangent is right here. You see this? So that is different, right? This is cosine, that is 0 for cosine, right here. And that is also 0 for sine, right? But for tangent, since tangent is right here, so, that is 0 for tangent. Okay? This guy. Okay, so, it's obvious that, you may choose this interval. This interval. You see that? Because for each point on the tangent in here, if you want to find the corresponding x, you want to go back to the x, you just connect with the origin. That will intersect with this part only at one point. So you are good. Okay? Similarly, you may guess already, right, about the cotangent. Cotangent is right here. So cotangent, you may choose 0, 0 and pi. Okay? So I can do a summary in here. The function y equal to psi of x has an inverse y equal to arc psi of x, and I would like to write in here when x between negative pi over 2 to pi over 2. The function y equal to tangent of x, I want to write this, right? When x between negative pi over 2 to pi over 2, tangent has an inverse y equal to arctangent of x. Okay? And the function y equal to cosine of x has an inverse when x between 0 and pi. That is arccosine of x. And y equal to cotangent has an inverse when x between 0 and pi. That is arccotangent of x. Okay, so the region we have arc right here, right? Arc right here. That means you go from side to the angle. You see, the arc right here. Look at this. If you have a unit circle, yeah, you want to find the function value, which is good. But if you want to find the angle, you need to go back, right, to the unit circle. So that's why you have arc in here, arc in here, arc in here, and arc in here. But the thing I want you to memorize is when you talk about sine, and tangent, so you are talking about the interval negative pi over 2 to pi over 2, okay? But when you're talking about cosine and cotangent, So you are talking about the interval 0 and pi. Don't forget that. So now if we are talking about the range and the domain of inverse functions, so we just need to look at the range and domain of the original functions. Psi of x takes value between -1 and 1, right? So that means -1 and 1 is the domain of the inverse arc psi. Is that correct? And the domain of the psi will be the range of arc psi, just like that, right? If you move to tangent takes value from 0 to infinity. This is from, the range of this function is 0 infinity. You can see that on the unit circle in here, from 0 to infinity. This is the whole straight line, right? So that means, arctangent defines no, I'm sorry, here should be negative infinity to positive infinity. Sorry for that, because that is the whole straight line. So arctangent is defined on negative infinity to positive infinity. Okay, of course we don't have negative pi over 2 and pi over 2 in here, because that is two points, right? The function is not defined those. And similarly, cosine is also not defined at 0 and pi. The limit at 0 and pi should be infinity. Okay, fix that for me, please. And so, for the cosine, you also have almost the same. Arc cosine is defined on -1 and 1, right? And of course, arc cotangent also from negative infinity to positive infinity. And those interval will be the range of cosine. This guy will be the range of arc cosine. This guy will be the range of arctangent. That's it. Okay. We will not talk about the graph of inverse functions, because we know exactly the graph of the inverse and the graph of the original function are symmetric with respect to the y equal to the x, right? So if you want to see the graph of arcsine, arccosine, arctangent, or arccotangent, you just need to graph sine, tangent, cosine, cotangent, and then take the symmetry, okay, with respect to this straight line, and you get what you need. Agree? So let's move to some examples. Let's evaluate arc sine of -1 over 2. Okay. So how to evaluate this? Okay. Suppose that this is x. We denote by x, right? Don't forget this. This is the angle, okay? So the angle will be measured in radian or in radius, okay? So let's denote by x. That means sine of x equal to -1/2. You see this? So, for such problem, I tell you, if we use the unit circle, you can see the answer right away. Look at this. We need to solve sine equal to -1/2. So suppose this is my unit circle. Okay. Since we are considering arc sine, that means, we are considering only this part, okay? From -pi over 2 to pi over 2. If we don't say anything, so we're just talking about that. The sine equal to -1 over 2. Where's that? So here is 0, here's -1, here's 1. -1 over 2 is right here, right? In order to find the x, means arc sine of -1 over 2, I just need to draw a horizontal line that will intersect with the circle, and that is the x you want to find. Does that make sense? So, right now, you might think, yeah, this is what? This is -pi over 6, means -30 degrees. Okay? Let's consider another example. Let's find arc cosine of 0. And now, I will use the unit circle, okay? Of course, you can put this equal to x, right? And what is that? That means cosine of x is equal to 0, right? And you need to find x. But if you want to use the unit circle, you see, it's pretty easy. Now, I'm look at the cosine. This is the cosine A6, okay? Cosine equal to 0. Where's that? Here, 1. Here, -1. The 0, that is the origin, right? So if you want, we know that we consider cosine on this interval from 0 to pi, right? From 0 to pi only. So if you are in here, you want to find, and if you are in here, right, 0, the value, you want to find the angle. So, you just need to draw the vertical line that intersects with the circle at this point. And that is pi over 2. That's it. So from here, I can see, yeah, x equal to pi over 2. You see? All right, let's move to tangent and cotangent, right? See? Let's evaluate our tangent of square root of 3. Okay? Again, when we are talking about tangent, remember that, we just consider angle x between negative pi over 2 to pi over 2, like for sine of x. Okay? So, the tangent is right here, right? I need to draw a tangent. That is the tangent, x. And tangent is equal to square root of 3, okay? So I think, yes, square root 3 might be around here, okay? Around here. And I need to draw, to find the angle, I need to connect that with the origin. That straight line will intersect with the unit circle at this guy, and this is what I need to find. A tangent of square root of 3. Okay, so you may put arctangent equal to y. From here you get tangent y equal to square root of 3. And we know that is only happen for y equal to pi over 3, or that is 60 degrees. Look at this. This is 60 degrees, or pi over 3. Okay, so similarly you can do for cotangent. You see, of course, I'll tell you, right? If you memorize everything in this, like, pi over 3, you have tangent equal to square root of 3, which is good. But, otherwise, you might use calculator. But the thing I want you to understand is how to use the unit circle. If you have an x on here, it's easy to find tangent. So just connect this, you get tangent in here. But if you have the tangent, right, the value of the tangent, you want to find the x, again, you go back to the circle. That is what we need to understand. Okay, the same situation for cotangent, sine, cosine. Now let's consider this example, and then we move to differentiation of inverse trig functions. They give us that y equal to arc sine of x, okay, and y is in between 0 and pi over 2. X is some number, okay, so and we know arc sine of x, okay. They ask us to find cosine of y, or if you write in a full form, that is cosine of arc sine of x. Okay, let me draw that out before we move to the solution. Again, I prefer to show this on the unit circle. Okay, so I have circle right here. Arc sine x, so that means x is the value, right? Because arc sine is angle, you see this? So x is a value on where? On the sine A6. Okay. And we know exactly y is in between 0 and pi over 2, between 0 and pi over 2. So it means the angle is only on 0 pi over 2. Let me just mention that. The angle is between 0 and pi over 2. Look at this. That is 0 and pi over 2. Okay, so x is the function value. X is the value on the psi axis. That is the psi axis. So x should be around here. Okay, let's say this is x, right? We don't know exactly x, but we know x should be 0 to 1 because y is in between 0 and pi over 2. Okay, so if you have an x right here, where is y? In order to find y, I just draw the horizontal line that will intersect with this part at some point. That is your y. Okay, so that is the angle. And now they ask us to find cosine of y. So now we are at the y. We want to cosine of y. We want to find cosine of y. It's pretty easy. You draw a vertical line. So that is your cosine of y. And that is what they ask you to do. Does that make sense? So from this picture, you will see, yeah, I know exactly cosine of y is in between 0 and 1. That's it. Okay. Now let's find it out. Of course, in this picture, you would think, okay, we can see some very common in here, some very familiar in here. So if I draw this, that is 1, right? Because the radius of the unit circle. So this is, psi of y. Okay. It seems like this is cosine of y. And, if you apply the Pythagorean theorem, you have 1 equal to sine square plus cosine square. Is it correct? But overall, I have the following one. Okay, let me write it down, right? Let me write what we observe in here, right, on this right triangle. So I can see on that right triangle, I have sine of y equal plus square, okay, plus cosine square of y equal to 1, okay. So if I want to find cosine of y, I need to solve this equation for cosine of y. I have 1 minus sine square of y. And then from here, I apply square root to both sides. I get, square root of 1 minus sine square of y. I need to explain a little bit. Usually, we should have plus minus in here, okay? But in this case, we have cosine is between 0 and 1. That means always positive, right? Not negative. So that's why I just write directly 1 square root of 1 minus sine square, okay? So that is what I got from the unit circle, right? Without any analytical solution from the problem. And from here, it seems like I don't have sine of y, right? I need to find sine of y. And then I just plug this in here. I get what I need. Agree? Okay, so let's do that from the condition of the problem. We have y equal to a arc sine of x, okay? From here, we have x is equal to sine of y. That's it. So actually, sine of y is equal to x. If x is given, we know sine of y, right? And then you plug all this into this identity, right? You get cosine of y equal to square root of 1 minus x squared. Done. That's what we have. Okay, but actually, you already see you may already see this identity on the unit circle. You know why? Because here you have 1. Is it correct? This is x, so this part should be square root of 1 minus x squared. So that is exactly cosine of y right here. You see this? So, sometimes if you use unit circle, you can solve that really fast. So I have x squared, let's write that, plus cosine square y equal to 1. That's what I see on this triangle. And from here, you can solve for cosine of y, that is 1 minus x squared square root. That's what we're getting here. Agree? Now let's talk about derivatives of inverse trig functions. It's pretty interesting. Okay, I will show you how to find inverse of arcsine. Arccosine, arctangent, arcotangent can be found similarly. Okay, so we just need to copy all formulas from the textbook. All right, let's consider the function y equal to arc sub x, and this is equivalent to x equal to sine of y, right? Okay, and we know that y is in between negative pi over 2 to pi over 2, and of course x is in negative 1 and 1. Okay, we need to find the derivative of this function using the derivative of this function, because we know that, when we study inverse function, we know if you have function y equal to f of x, this function is differentiable, okay, then the derivative of the inverse function can be found by this formula: 1 over derivative of the function evaluated at the inverse. Okay, now we will apply this formula to find the derivative of arcsine. Agree? So I will have the function in this case is what? Is sub x. Okay, I know if the derivative of sub x is cosine of x. Okay, but I need to evaluate the function cosine at the value of the inverse, right? At the values of the inverse. So that means this is nothing but cosine of arc sine of x. You can see something familiar. We just did that in the previous example. You see this? Cosine arc sine. You see this? All right. So we know that this is what? This is square root of 1 minus x squared. Right? We just did that right here. Or right here. So I just copy that result to this. Agree? So basically, I have the derivative of arc sine of x equal to 1 over the function value is already right here, right? We already calculate that, just square root of 1 minus x squared. Okay, so this is the formula we need to memorize. If we use the chain rule, we will have the following formula: arc sine of u derivative equal to u prime divided by 1 minus u squared. Okay, so you can do very similar steps. First, you can do like this problem, right? To find, let's say, let me formulate that. You might have y equal to arc cosine of x, and they ask you to find sine of y, right? So if you use this, you can find the derivative of arc cosine. Okay, so we will not do that. I just need to copy everything from textbook, right? So if you want, you can do that yourself. We have arc cosine of x derivative. This is also equal to negative u, negative 1, sorry, negative 1 divided by 1 minus x squared with the square root in here. And if we have function over there, you take derivative, you get negative u prime over square root of 1 minus u squared. Okay, For arctangent, you have the following one. 1 over 1 plus x squared, and if you have the function u over there, so you have 1 over u prime, 1 plus u squared. And for arctangent, you have negative 1 over 1 plus x squared. And if you have a function u, so you get negative u prime 1 plus u squared. About sequence or cosequence, so I think you can see in the textbook, okay? I just want to concentrate on sine, cosine, tangent, and cotangent. And one thing I want to mention in these 4 formulas, if you differentiate the function psi of x, you don't have a negative in here, just everything with the plus. You do almost the same thing with the tangent, you have plus in here. But if you do with cosine, you get negative 1. If you do with cotangent, you get negative 1 in here. Or negative u prime or negative u prime in here. Don't forget that. So, there is some pair, right? Sine, tangent with positive, cosine with cotangent with negative. Okay? Again, right, please make a formula sheet for yourself, because sometimes we don't remember everything in here. Let's consider the following example. Y equal to x sine of x plus x square root of 1 minus x squared. So we have x sine, we need to find y prime, okay? So I have y prime equal to x sine prime plus, for the second term, we need to use the product rule, right? So let me do that because that is easier. 1 minus x squared plus x, and then derivative of 1 minus x squared, okay? So let's find them separately, and then we compile everything, we get the result. X sine derivative is 1 over square root of 1 minus x squared. Okay, here 1 minus x squared plus x. So, I need to use the chain rule, right? Let's find this separately in here. 1 minus x squared to 1/2, that is square root. So I apply the chain rule. I will get 1/2 times 1 minus x squared negative 1/2, and then times negative 2x. Negative 2x comes from the derivative of the inside function. Okay, so if you simplify 2 with the 2 in here, I get negative x times 1 minus x squared to negative 1/2. But what is negative 1/2? Sometimes you need to rewrite this as negative x divided by 1 minus x squared to 1/2, right? And that is nothing but negative x over square root of 1 minus x squared. Okay, so the derivative of this function is right here. I just need to copy that and put into the formula. So I have times negative x, okay, divided by square root of 1 minus x squared. Let's see if we can simplify this or not. I have 1 minus x squared in here plus 1 minus x squared in here, and then minus x squared 1 minus x squared in here, square root. Actually, we can simplify this, right? We have common denominator, which is square root of 1 minus x squared. Okay, let's simplify this. I have 1 plus, I multiply this guy with this guy, so I have 1 minus x squared, and then minus x squared over square root of 1 minus x squared. So on the top you have 2 minus 2x squared over square root of 1 minus x squared. It looks pretty nice, right? Because you have 2 in here, and then 1 minus x squared divided by 1 minus x squared, and that is 2 square square root of 1 minus x squared. It looks pretty nice. The function looks very complicated, but the derivative is pretty nice. You see, this is your function. And the derivative looks like y prime equal to 2 square root of 1 minus x squared. So I think I finished my video right here. There are a couple of examples in the textbook, but I think we can skip them. In this video, we study inverse function, unit circles, and differentiation rules for inverse function, right? Again, right, please make a formula sheet for yourself, and I really recommend you to work with the unit circles, because in my experience, if you understand this, you will work with trig functions without any difficulties. Okay, so hope you enjoyed the video, and see you in the next one. Bye bye.